Hello folks, I hope you had a good break from school over the holidays. I certainly did. This time we're going to work slightly differently in that I'm going to try and post something for you every day when you would have maths. And it shouldn't take any longer than a normal lesson in school would. And I'm going to do this mostly through video so that you can play the video and I'll come on and talk to you, explain things, show you how to do stuff. Then you can pause the video and practice and we will make some notes perhaps and go over your work to make sure you've got it right. There may also be something that you've got to do at the end, perhaps a single question or your opinion or a rating or something, so that I'm getting some feedback from you. If you want to contact me, the best way to do that is through email. That will be using the normal Glow email address, a.fin, and I will try and get back to you that day. I will normally be here at least from 9 till 5, although there may be times when I am in school, and obviously I will post that on Teams to let you know about that. And if you have any comments, if there's anything that's not clear, or if you think there's anything you can improve, or indeed if you think I've made a mistake, because I am human like you, do let me know please. I'll be delighted to hear from you in these strange times. Okay, let's get started. I'm sure you remember, folks, back in first year, there were two things you could do with a rectangle. One was you could work out the total distance all the way around the rectangle, along here and back to where we started. And remember, that was the perimeter of the rectangle. And depending on how big the rectangle was, we might measure that in millimetres, centimetres, metres, or I suppose even kilometres if it was a big area of land. But there was something else you could do with a rectangle as well. You could also find how much space there was actually inside the rectangle. How many squares there were inside the rectangle. And of course, to do that, you would do length times breadth, and your answer would come out depending on whether you were given measurements in millimetres. It would be square millimetres, centimetres, centimetres squared, metres, metres squared, and so on. Okay? And these are two-dimensional shapes because they have length and breadth. And of course, if you have a three-dimensional shape, like this, remember that shape is called a cuboid. We could find the volume of that cuboid, which was how many cubes of a particular size would fit inside it. And the volume of that cuboid would be length times breadth times height. So, if we have a cuboid, let's say that is this one here, bad drawing, 10 centimetres by 3 centimetres by 2 centimetres. To find the volume, it's that old story, we need to show that we can remember the right formula. We need to fill in the right numbers, 10 times 3 times 2. So that is 30 times 2, 60. And because it's a three-dimensional shape and we're finding the volume, it's centimetres cubed. Okay, so we're going to start working on volume now, and we'll do a wee bit revision about cuboids, and then we'll move on and extend your knowledge of volume to finding the volume of other shapes, like for example a cylinder or a triangular prism. Okay. First of all, we need to make a wee note. So our learning intention for this is remember, because this is not something new, and we'll keep the note nice and short. Remember how to find the volume of a cuboid. So if you could write this down, remember how to find the volume of a cuboid, either in your notes jotter or in the back of your jotter. All right. A quick example let's keep it simple. I always find it's easiest to draw a cuboid by drawing the front rectangle and then just adding some bits going back diagonally like that. Okay, so let's put in some sizes. Let's say this is 12 centimeters by 4 centimeters by 3 centimeters. So remember, the volume of that cuboid is going to be, show that you remember the formula, because we're going to learn a lot more formula for different kinds of shapes. 12 times 4 times 3, which is going to be 48, times 3 is going to be 120 plus 24, 144, and make sure we get the cubed in. So remember, our success criteria for doing this are formula, working, and answer with units. Okay, I'll have a wee exercise for you just to practice that for a few minutes. Okay, hopefully that was pretty easy, and here are the answers to that part. And then we'll move on and solve a couple of problems using our knowledge of how to find the volume of a cuboid. Okay, let's call this problem number 7. And the context we're going to think about is a dairy. And in the dairy there is a big tank of milk. Here it is. And it is 100 centimeters long, it's 80 centimeters wide and 80 centimeters high. And that tank is full of milk. And we're going to use that to fill a carton. And the cartons are obviously much smaller. So the cartons we're going to fill are 10 centimeters by 10 centimeters by 20 centimeters. So your challenge is how many of the cartons can be filled. How many cartons can be filled from that tank of milk? Okay, hopefully you've got your answer now. Let's see if we get the same answer. First of all, we need to find the volume of the tank. And that's going to be length times breadth times height. And it was 100 times 80 times 80. So when I work that out, 100 times 80 times 80 is going to be 640,000. Make sure we get the right number of zeros. 640,000 cubic centimeters. Then we need to know the volume of the carton. And the carton is obviously a cuboid too, so it's length times breadth times height. And the carton was 10 by 10 by 20, which is going to be 2,000 cubic centimeters. Now you're not finished there, because the question was asking you how many of these can you get out of this. So to find how many 2000s are in that, we have to do a division. So it's 640,000 divided by 2000. So we're asking how many 2000s are there in 640,000. And the answer is 320 cartons. So from that big tank, you could fill 320 cartons of milk. Okay, let's have another problem for you to solve. Okay, here's number 8. We're thinking about a big cuboid. Let's say it's 20 centimeters long, 10 centimeters wide, and let's say about 7 centimeters high. But there's been a hole cut through it so that you can see through, right? So that hole in the middle goes all the way through, right through to the ground if you like, and it is 4 centimeters by 10 centimeters. So my challenge is, can you work out the volume of material in the cuboid? Okay, and pause there and have a shot. Okay, hopefully it was obvious that the first thing you do was find the volume of the big cuboid. And that would be length times breadth times height. And as I say, soon we'll have lots of different formula to worry about. So it's 20 times 10, 200 times 7, which would be 1,400 centimetres cubed. Then obviously I think we're going to find the volume of the hole and take it away, because it's like it's been cut out. So you started with 1,400 centimetres cubed of wood or whatever it's made of, and you cut out a bit in the middle. So the volume of the hole is length times breadth times height. So the length of that hole is 10. What's the height of it? Well, remember I said it went right through, so if it goes right through, it must be 7. So 10 times 4 is 40, 40 times 7 is 280 centimetres cubed. So the volume of that particular shape, simply a take away sum to finish, 1,400 take away 280 is going to be 1,120 centimetres cubed. Okay, so we've learnt the basic, or we've remembered the basic way to find the volume of a cuboid, and we can see that there are a few problems that we could solve using that. Okay, something else that you learnt along with the work and volume was how to convert between cubic centimetres, which is the natural unit we use a lot of the time because we're mostly dealing with objects that are measured in centimetres. So the lengths are in centimetres, the volume comes out in cubic centimetres. But of course, you'll have noticed, for example, in a milk carton that it doesn't give the volume there in cubic centimetres, it gives it in litres. So something we need to note, and you could add this to your note, or your notes jotter, or just put it in your jotter, is that 1,000 cubic centimetres equals 1 litre. And the symbol for litre that we sometimes use looks like an E, but it's actually an old-fashioned L, so that when we write it, it doesn't look like, for example, if we write 2 litres, we can see that it's clearly 2 litres. It doesn't look like we've written 21 as it might if we just used a normal L. Anyway, 1,000 cubic centimetres is a litre, so a cubic centimetre, 1 cubic centimetre is equivalent to 1 millilitre. So if we could put that down as a note, and let's have a few examples just to accompany that. So if we've got 2,300 cubic centimetres, we would say that was 2.3 litres. If we had 450 cubic centimetres, that's less than 1,000, so it's less than a litre, 0.45 litres. Remember, you don't need to have the extra zero there. It's not wrong if you put it, it's just not necessary. And if something was 40,000 cubic centimetres, that would be obviously 40 litres. And we need to convert the other way around, and that's where this issue with the zero becomes important. If we have 6 litres, that is 6,000 cubic centimetres, or 6,000 millilitres, of course. If we have 0.7 of a litre, however, we've got to remember 1 litre is the thousands column, so this is in the hundreds column when we're dealing in millilitres or cubic centimetres, so that's not 7 cubic centimetres, that's 700 cubic centimetres. And if we have something like this, that would be 830. Yes, because that's thousands, that's hundreds, that's tens, 830 cubic centimetres. So if we were to have this, that would be thousands, and that's tens, so that would be 80 cubic centimetres again, or millilitres. So we'll just have a wee pause to get that written down, and we'll do a wee bit of practice on that, and then we'll look at combining that with some volume calculations. Okay, here we are, exercise 2. Obviously in the first 5 I'm expecting you to write down what that volume would be in litres, and notice I'm switching between litres and millilitres and cubic centimetres. And questions 6 to 10, we'll write that down in cubic centimetres or millilitres. The answer will be the same in both. Okay, so I'll give, if you pause here and get that done, and then in a minute I'll put the answers up for you. Okay, here we are, here are the answers so that you can check your work. Remember, in questions 6 to 10, it doesn't matter whether you said millilitres or cubic centimetres, they're essentially 2 different names for the same amount of stuff. Okay, and we'll just have one exercise. Okay, here we are, here's today's final exercise. I would like you to calculate the volume of these cuboids, and then I would like you to convert your answer into litres. Okay, I'll show you the answers to these in just a minute, so pause and have a shot at these. Calculate the volume, showing the working, and give your answer in litres. Thank you. Okay folks, here are the answers for the exercise you've just completed. 0.96 litres for the first one, 0.89 for the second one, 0.18 and 0.216. Remember, the important point is that 1,000 centimetres or millilitres in each litre. It was good to work with you today, folks. I hope that was fairly straightforward. Before you stop, though, there are a couple of things I want to mention. First of all, there should be in your teams a little question for you to answer. It's important you do that, so that, because obviously I can't see your jotter, and that way I'll know that you've learned what you needed to learn and maybe give me some feedback. If there's anything you want to contact me about, remember it's a.fin@angusschools and so on, and I'm happy to hear from you. And finally, we will be organising a live get-together at some point during the week, so we can just see each other, check in that everything's okay, ask any questions, because sometimes it's easier to ask in person, because it is not always easy to say what you mean in an email. But obviously I'm happy to get any questions, anything I can do to help you out. Okay, see you tomorrow. Bye.